Let's talk about trampolines, solar panels, and electric charge. To review, particles and the things they make up can be electrically charged due to having an excess or lack of negatively charged electrons. So how do we conceptualize and quantify what a charged object does to the space around it? Well, let's say we have an object that is charged to -3 coulombs, our base unit of charge. Based on what you may have heard, you're probably thinking it should attract positive charges around it and repel negative ones. But we can do better than that. Instead of focusing on any specific interaction, we can generalize the effects of the 3 coulomb charge on the space around it by finding its electric field, aka the area in which we know other particles would feel a force. Think of a trampoline. We could measure how high one singular ball bounces, or we could study its bounciness and find out what effect it would have on anything that fell on it. And to find the bounciness of the space around the charge, we can use electric flux. Electric flux is the amount of electric field piercing a given amount of area. Think of it like placing solar panels all around the sun. The rays of the sun that pierce the panels head-on get collected by the panels, head-on meaning perpendicularly, and the rays that smash right into the panels are all that get collected. Similarly, electric flux only takes into account the electric field that smashes right into the place at which you're measuring it, which we call a Gaussian surface. The area in our formula will refer to the surface area of the Gaussian surface, since that's what the rays hit. Now we can use Gauss's law, which looks like this, to easily calculate the electric field at any distance from the charged object. For a sheet of charge, we'd use a Gaussian prism. For a circle, we'll use a sphere, and for a line of charge, we can use a cylinder. You'll notice that as we move further from the charge, since the Q enclosed stays the same, an increased area must lead to a decreased magnitude of electric field at that point to keep Q constant. In a nutshell, the solar rays get less severe as we move away from them. Hopefully, this makes sense. Charges feel a stronger force up close. Thank you for watching.
Created using Powtoon.